Okay, so we've got a problem here dealing with the current populations as of 2012 of the United States and China. So the United States is at about 312 million people. If we write this in scientific notation, we want to start with a number that's between 1 and 10. An easy way to get that number from this large number is just to place a decimal between the 3 and the 1, because then we get 3.12. That's between 1 and 10, and within the range we need. I can't put that decimal anywhere else, right? If I put it before the 3, what would I get? I would get 0.312, which is not between 1 and 10, so that doesn't work. And I can't put it between the 1 and the 2 because it's 31.2, and so forth. Now the question is, well, what would I have to multiply 3.12 to get 312 million? Well, the answer is 10 to the 8th. How do I know that? Because, well, originally our decimal was here, 312 million. I moved it. When I put it between the 3 and the 1, I moved it 8 places to the left. In other words, I took this large number, divided it by 10 8 times. To balance that, I just do the opposite. I multiply it by 10 8 times in a row, right? 10 times 10 and so forth. And these numbers are equivalent. China will have a similar type of strategy because they're both positive numbers. Here we have 1,350,000,000, so it should have a higher power of 10. I put my decimal now between 1 and 3 to get 1.35. It's between 1 and 10. Multiply that by 10 to this time 369, the 9th power. Because why? Well, again, I move my decimal 9 places to the left when I put it between the 1 and the 3. To balance that out, I should bring it 9 places to the right. If we want to know, though, how many times larger the population of China is than the US, we could divide. Population of China, over 1 billion, times 10 to the 9th, divided by 3.12 times 10 to the 8th. The part that's easy about this is you can just divide 10 to the 9th divided by 10 to the 8th. And that's what? Well, you subtract the exponent, so 9 minus 8 is 1. So now we could divide our factors here, right? We pull up our calculator. We can just do what? Well, 1.35 divided by 3.12. And there we get 0.43269230077. So we could write that whole number. We could estimate. There aren't many guidelines here in the problem, so I'll just try to make a reasonable estimation. If the number was 0.43269230077, I could just round it to what? 0.4327. It was 0.43269, so I just rounded it up. A fairly close approximation. I want to write this in scientific notation. So I multiply this number by 10, right? I put that decimal between the 4 and the 3. Gives me a number between 1 and 10. And then I multiply it by what? Well, if I multiply this by 10, I don't want to change my number, so I divide this one by 10. I get 10 to the 0. So now, right, 10 to the 1 divided by 10, that's just 1, or 10 to the 0. And this is, of course, is 4.327. Again, this is just 1, right? X to the 0 is 1, right? When x is not equal to 0. That's another conversation. So if you basically start with a number that's not 0 and you raise it to the 0 power, you should get a 1. And so anyway, we get our answer, 4.327 times larger. All right, thanks a lot.